Hello guys, I am Satyam and you are here on our one and all channel Satyam IGL Learning. And today we are going to start with our new topic, latent heat of fusion as well as latent heat of vaporization. So let's start with our new topic. At the very first we have to do an experiment and we have to take an iron stand, and with the help of an iron stand we have to suspend a beaker. Beaker not. We have to suspend a thermometer. Hang a thermometer, okay? And we have to take an wire gauge, tripod stand and Bunsen burner and a beaker on the wire gauge. Clear? So this is how we have to make it. This is iron stand. Roughly I am drawing only. And this is how iron stand is holding this thermometer. And you have to make sure that the bulb is surrounded by ice cubes which you are putting on it. Putting in the beaker, okay? You have to put 100 gram of ice cubes in that beaker. Clear? This is the material of the experiment. Now, you will notice the temperature at the very first. It is 0 degrees Celsius. Now what you have to do, you have to switch on the flame of the Bunsen burner. And you will notice that the ice start melting, okay? It starts melting, and when it melts, till the ice fully melts, you will notice that the temperature is still 0 degrees Celsius. Now why the temperature is still 0 degrees Celsius? Because the heat which you are providing the ice is stored in water into which it melts, okay? So the heat energy which is provided to the ice is stored in water in the form of latent heat, because it changes into water and still there is no change in temperature. It is 0 degrees Celsius only. So latent heat is the cause. So latent heat is stored in water, okay, in this case. See, now latent heat of fusion. What is latent heat of fusion? Amount of heat energy supplied to the solid at its melting point. And ice melting point is 0 degrees Celsius, such that it changes into liquid state without any rise in temperature. There is no rise in temperature, and that is known as latent heat of fusion. Clear this thing? Now, what is this? These numberings which I have written here, these are specific latent heat of fusion of ice. Specific latent heat of fusion of ice. See, the heat energy, amount of heat energy required to change 1 kg of ice at 0 degrees Celsius into water at 0 degrees Celsius, that is called specific latent heat of fusion of ice. Clear? And that is 336 into 10 raised to power 3 joule per kilogram. Why this is? Because I have said what? I have said the amount of heat energy required to change 1 kilogram of ice at 0 degrees Celsius. 1 kilogram of ice. When we say 1 kilogram of ice, then this numbering will come. 336 into 10 raised to power 3 joule per gram. Because, see, and when we say we have to change the amount of heat energy required to change 1 gram of ice at 0 degrees Celsius into water at 0 degrees Celsius, then this numbering will come, 336 joule per gram. You have to remember this numbering only, and when it comes into kg, then you have to multiply it with 1000 only. This is the thing only. And joule, you know, it is the unit of energy, and we are talking about energy only, na? The amount of energy. So that is the specific latent heat of fusion of ice. This is the value, experimental value. Okay, you have to learn this, 336 joule per gram. Clear? Now, we are coming on latent heat of vaporization. And you have to remember, latent heat is the hidden energy. Okay, latent heat is the hidden energy. Latent heat of vaporization. Now see, what is latent heat of vaporization? when we heat the liquid, now see, the ice has changed into water, and now what I will do, see, this is the water, and I will heat it more. What will happen? The temperature will start rise, and at the point when it comes at 100 degrees Celsius, you know now what is 100 degrees Celsius? It is the boiling point of water. 100 degrees Celsius is the boiling point of water. Okay, so when the temperature rises to 100 degrees Celsius, then what will happen? This water starts boiling and it will change into steam. Okay, it will change into steam. And this water, until every drop of water changes into steam, the temperature will remain 100 degrees Celsius only. Clear, guys? So until every drop of water changes into steam, the temperature of this water will be 100 degrees Celsius only. This is also the same latent heat of vaporization. Amount of heat energy supplied to a liquid at its boiling point such that it changes into gaseous state without any rise in temperature. There is no rise in temperature. Clear? So the liquid change into gaseous state into steam. Till every drop of water changes into steam, the temperature will be 100 degrees Celsius only. So there is no rise in temperature at the boiling point. Okay. There is no rise of temperature, is called latent heat of vaporization, and that is only known as latent heat of vaporization. You know, melting is also known as fusion. Okay, and vaporization you already know. Boiling is known as vaporization. So change of solid to liquid is known as what? Melting or fusion. And change of liquid to gaseous state is known as boiling or vaporization. You already know these things. You have learned it in 6th class. And now see, what is this? This is also the experimental value. It is also the specific latent heat of vaporization. Okay, this is the experimental value. Now, when we, so the amount of heat energy required to change 1 kilogram of water at 100 degrees Celsius to steam at 100 degrees Celsius, then this experimental value will be there. That is known as specific latent heat of vaporization. Okay. So this is 2260 into 10 raised to power 3 joule per gram. So the amount of heat energy required to change 1 kilogram of water, 1 kilogram of water at 100 degrees Celsius into steam at 100 degrees Celsius, that is called latent heat, specific latent heat of vaporization. Specific latent heat of vaporization. Okay, specific latent heat of vaporization. And this is the experimental value. And when we talk about gram, that the amount of heat energy required to change 1 gram of water into at 100 degrees Celsius into steam at 100 degrees Celsius, then this experimental value will come. So you have to learn this only, 2260 joule per gram. This experimental value you have to learn only. And when it comes about kg, then you have to change it by multiplying into 1000. Okay, by multiplying it with 1000, you will change it into kg. And you know, joule is the joule is the amount, SI unit of energy. Okay, so we are talking about energy only, na? That is why it comes. So this is about specific latent heat, and latent heat also we have done today. Latent heat of fusion as well as latent heat of vaporization. I think you must have been clear all your doubts related to this topic. So bye bye, we'll meet in the next time very soon. Thank you.